So let's move on now to the 2022 season. Well, what can you say? It was an extreme one, a hummer of a summer, I've called it. I love the picture of the hummingbird hawk moth. You just can't beat them. And you might have noticed on our sightings page that somebody has seen one literally, I think about 3 days ago in Horsforth near Leeds. It obviously just come out of hibernation. The numbers last year were amazing for the hummingbird hawk moth. Matthew Oates made it his butterfly of the year, even though it is a moth. It got promoted to being a butterfly. And the simple reason is there were 10 times more than any other previous season. An amazing, amazing fact. This is just the headline figures for the season. It was extreme heat. We're never going to forget the some of the temperatures. I think like I did, we try and get our transects out the way in the morning if we had to do one on a hot day. You couldn't really, it was seriously dangerous to go walking after 11 o'clock. And certainly I would strongly advise anybody when it gets above 30 not to walk your transect after 11 o'clock. It was also a very good year for migrants, but not migrant butterflies, migrant moths. And you might have saw Charlie Fletcher's moth roundup of the year. It was very much dominated. The headlines were dominated by huge numbers of new migrants appearing in the UK. It was a record year for migrants appearing. Of course, the big story, I think, with when you look at the figures will be the effect of drought. But also in there, one we haven't talked about before, and that's the effect of parasites. And some of them I have caused both booms and busts. And the first two here, the two biggest winner, Holly Blue, is all about overcoming its parasite, and small tortoiseshell, huge drop in numbers this year, is all about really is being badly affected by a parasite, but also the drought. But let's get on to now the weather. Thanks for Dave Ramsden for these graphics. And let's just add a bit of meat to the story here, because weather with butterflies is almost everything really. They cannot raise it. They can only raise the temperature a little bit. They are dependent on the weather to warm themselves up to be able to fly. So to be able to reproduce, to be able to fly, you got to have warm weather. Hence the Pollard rules. You shouldn't walk without sun and a temperature of at least 14. Those are the minimum requirements for flight. What you can see is, let's just go back to autumn 2021, because a lot of species, what happens, especially the overwintering species, and autumn 2021 was very sunny, very warm, lots of nectar around. It was great for hibernating adults, and they were seen well into the autumn in quite large numbers. So that meant that we had a good start for them. The other good news about the last autumn was November, when many of our species caterpillars, the other stage in which they hibernate, was dry. That's important because one of the main casualties for our species is November weather. If it's very wet and very warm, it's deadly for caterpillars. The other thing is, if the early December, if it goes cold pretty quickly, that stimulates them to go into hibernation and not come back out again, which helps obviously their survival. Winter, as you can see from up here, was very, very mild. And I remember on the TV seeing lots of news clips about birds beginning to nest in February. It was incredibly warm in February. And that, I think, added quite a bit to the year. Spring in general was very warm. It's up 1.3 degrees. But more importantly, March was extremely sunny. It was also the start of the dry. The east half of the county in particular, East Yorkshire, was very dry. As you can see here, overall, it was just about average, but the eastern side of the county was very dry. Summer, I don't need to tell you, we had 3 heat waves. It was nearly 2 degrees hotter than the average. We peaked in mid-July. You remember the big peak. It hit 40 degrees centigrade in the south of the county. Summer rainfall was less than half the average. So not only do we have a dry spring, but we had a very dry summer. This quite rapidly limited plant growth and nectar supply. And I'm afraid a lot of the rest of the story of our butterflies is to do with those two things. Crucially, I think just as we thought things couldn't get any worse, we had some rain in July, which I think probably saved a lot of butterflies. It partly revived our grasslands, just as a lot of them were laying eggs. This only applies to north of the, I would say, Doncaster. South of Doncaster, South Yorkshire in particular, they never got this sun. And their lawns, etc., just stayed yellow. I know my lawn turned green quite miraculously after the rain, and it was only a very short spell of about 1 day, but we got quite intense rain, and maybe a couple of inches fell, and that revived things enough. Heat wave returned in August, and then unfortunately the season just seemed to end abruptly because there was so little nectar. And that is the other part of the story, really. It drove a lot of species to hibernate very early. Let's move on and actually see what happened. Now, you might remember last year when we started to introduce this method of looking at our data. So what you see here is the various species, half the species at least, the number of transects that are up and the number of transects which are down. And then we compare it against the 5-year average. So we got some degree of, how does it compare? But we also look at the Yorkshire 1-year trend, which is the next column here. So how did it compare with last year? So I'm not going to linger too long on this, but you can see that Brimstone in particular was up. The skippers held their ground. The whites, or particularly the large whites, suffered. The orange tip was up. 23 sites were up, so only 16 were down, even though we only saw a 5% increase in numbers. Similarly, the Brimstone, 20 up, 14 down. And you can see how this confirms our thinking about this number, because every site is different. Some go up, some go down, and there's lots of reasons, mostly to do with the site, but also a lot to do with what landscape they're in. So, for example, this year, the limestone sites on hills have suffered very badly with the drought, while in the Vale of York, on clay, water-retaining soils, it's been much less noticeable. And you'll see it in the figures that if you look at your transect, you can, depending whether it's gone up or gone down, will largely be determined by your soil type as much as anything else. Now, sorry, I went too fast. We only have one site with the Duke and Burgundy. It was slightly down against the 5-year average, but up compared with last year. It's holding its own, just. The big down story is Green Hare Street, down on 5 sites, seem to have a very large decrease. I think that's related to the drought. And all the other Lysinids, the blue families, were almost universally down as well. However, there's one big exception here, and that's amongst the brown Argus. So the brown Argus, we have two different types of brown Argus. So we have the brown Argus that lives on rock grove sites, and the brown Argus, which is very widespread, quite migratory, never stays very long in one place. The cranesbill, the newer form of brown Argus, which feeds on cranesbill, they were well up. I think they were up a factor of 3 or 4, and they were seen all over the place, which just shows the difference, even within one species, how plants make a difference. Common blue was a bit down, but of course the other big headline is holly blue. So in my predictions, and you might remember a few of my predictions last year, we said we thought that holly blue was going to go up rapidly, simply because the second generation last year showed a significant increase from an absolute pits bottom in the spring. It was one of the worst times for holly blue in recent times. And we'll look in more detail at that when we do the 30-year review. But the spring this year was almost a factor of 20 higher than the average, which is amazing. It shrugged off its parasite. It's lost its parasite temporarily. The bad news is, by the second generation, the parasite was back. But even so, it managed to do nearly a 5-fold increase on last year, and 52% up on the 5-year average. So that's been a real winner. Let's move on to the other species. I guess the other big story, sad story really, is small tortoiseshell. It almost failed to have a second generation, apart from in the upper and the cooler areas of the counties. After 2 years of booming, when we'd never seen so many small tortoiseshells, it went firmly bust. And unfortunately, it took peacock with it. And both of them are at a very worrying low. I really don't know what's going to happen in the next few weeks to both those species. There are a few being seen, but to be honest, and maybe if Catherine's done her look at the figures for what's been coming out. Catherine, can you tell us what the scoreboard is like?
There's been 5 species seen so far, of which Brimstone, we've had 16 sightings.
Yeah.
Comma 9.
Yeah.
Small tortoiseshell 4.
Yeah.
Peacock 2.
Yeah.
And Red Admiral 1. So
interesting.
Well, quite a few commas, so that's really good, and a lot of brimstones.
Yes.
So a good start, really. 32 in total.
Thank you. Thank you, Catherine.
Yeah.
That's interesting. That would have exactly matched the kind of prediction in some ways, because comma was exceptional this year, and that may be the reason why it scored second highest in our quick survey tonight. It's 100% up on last year, 21% up against the average, and the summer generation was the so-called Hutchinsoni generation. That's a generation which is able to reproduce, because normally normal commas are not sexually mature when they emerge in summer, and they are the ones that hibernate. But if they manage to achieve their life cycle before basically become a pupa before Midsummer's Day, they hatch as the form Hutchinsoni. It's colored differently, so it's a much brighter golden. The spots are much smaller. It's just a different form, and this year Hutchinsoni was exceptional, up by I think a factor of 4 or 5 compared with previous, and that means that there was another generation. The big problem with both those species is small tortoiseshell and peacock is they suffer with parasites. And we're just going to talk about that. When I talk about tortoiseshell, I'm going to show you a bit more detail about that. So good news about the comma, the speckled wood. Now you would think in the heat for a species that likes, which is a grass feeder, it would really suffer in the drought. Well, it hasn't. It's absolutely boomed up against the 5-year average and nearly 50% more than previous year. They really have had a good year. Wool. Now that's another story which I'm going to elaborate on in the 30-year review. Has had yet another good year. More than 40% of our monitored sites now have wool. It's up about another 8 sites this year. They are on the move, and there's a lot happening with wool. Gatekeeper is boomed again. And you might remember when we got to August, there were very few butterflies apart from gatekeepers. They were the last of the survivors in the heat, and they really did boom. Many of the other browns also boomed. The marble white had an amazing year. I wouldn't have believed if somebody said that I would get a marble white in my garden in the middle of farmland in a cereal prairie south of York, I would say you're absolutely crazy. Well, this year I had a marble white in my garden, and many other people had them too. This year was also about dispersal. There was a big preponderance of species dispersing in the heat that we had. And I think this year had to rewrite most of the rule books about dispersal because it was happening over very big distances, not just the odd few miles, not just blown down off the wolds. It was happening wide scale in big numbers for a number of species, but definitely the marble white. Let's move on. Okay, I promised you a look back in time. And this is very much in our TARDIS. We're going to go back to 1990. Just take a deep breath before you look at this and just look at first the blue line. The blue line is the average mean maximum temperature in summer for each of those years from 1990 to 2022. And what you notice straight away is there are various peaks along that line, the biggest peak being 2022, as you would imagine. It was exceptional. But there have been other peaks along the way, and some of them were quite close to the 2022 peak. The reason I'm interested in this measurement is it's all about butterflies. So butterflies enjoy that warmest part of the day. That's when their life cycle is going on. They're not really functioning during the winter, apart from hibernating. And summer, we know summer is a critical time for them. If we get a good summer, we get good numbers of butterflies. So you'll see the blue line and you'll see the peaks, and you might remember some of these years, certainly I do. 95 in particular, very sunny year, very hot. The next one was 2003, but 2006 was also an exceptional year. Now then something interesting happens. 2013 and 2014 were both hot years. And then 2018, 2019 were 2 hot years. When you get 2 hot years together, interesting things happen. And let me explain. The other lines you see here is the red dotted is sunshine hours. And the green dotted is rainfall. And you can see the drought of 95 was worse than the drought of 2022. And the sunshine of 95 was in excess of this year by a considerable margin. It was our last really big cracking year. And that's the year I think we will refer to. The only one that came anywhere near close this year and 2018 was very close. The interesting bit here is the purple line. So the purple line is the abundance of all species. So what I've done is added all the indexes of all species across all transects, add them all together for each year and take the average. And what you see is I've altered the scales so that you can see the detail. And we're looking here the abundance index for a year. So this is a total number of insects seen from 200 to 1300 insects. So 200 is down there and 1300 will be up here somewhere. So this is the average. Obviously there's some big peaks because we've seen some 3,000, 4,000. There's also some which are very much lower. This is the average. And what you see is a dramatic effect of temperature, much bigger than you possibly would imagine. So a change of 2 degrees causes the abundance to drop from 800, say, down to 400. So for that small change, you halve the abundance. It is quite dramatic, and you see it following the seasons pretty exactly. When you get 2 warm years together, it kind of amplifies the effect, and it also delays the effect. So 2 warm years together really does bring on a surge. And you see here in the 2018, 2019, both of them were good years. It is shifted towards the 2019. And you see here 2022, where it's really shot up again. It's not going to be anywhere near 2018, but we're going to get quite close. So the headlines of all this, which I think is the interesting bit of the work that we've done, is the mean temperature has gone up 0.7. The maximum, which you see here, has gone up 0.9. The rainfall in Yorkshire has gone up 27% in that 30-year spell. Sunshine hours only slightly, but look, a butterfly abundance 25% up. That's the headline. I know it doesn't match anything you read in the press. It surprised me. But if you read the latest state of UK butterflies, you will see that in the last few years, almost everywhere in the UK has seen an increase. Certainly in the last 20 years, it's definitely been quite a strong increase. And if you go to Scotland, in other words, halfway between the big butterfly areas in the south, we're kind of halfway between. And we live in an area also which is the northern edge of so many species. And that edge is moving forever northwards. When that edge moves northwards, it's usually accompanied by a big surge in abundance. And when we look in more detail at this, we'll see some of this effect. So we're going to look now at another bit of a mind-blowing graph. It's similar in that red is negative, green is positive, and we look at the latest figures from the whole of the UK, and we see what I've just been talking about, but expressed in terms of all the species. So out of the, I think, 26 species, only 6 species are actually going down. They're not always the ones you expect. So yes, we could expect the habitat specialist small pearl bordered is suffering, is still going down. It is a serious issue. Small tortoiseshell going down very quickly. Ringlet going down. Gatekeeper going down. Not ones you necessarily expect. But look how many are green. And some of them are having huge increases. The whites are doing well. The orange tips are doing well. Brown Argus doing exceptionally well. The holly blue exceedingly well. If we look at our trends, we see very similar trends where you'll see where it's green on one side, it's green on the other. And the numbers are not dramatically dissimilar, which proves the work that we do, and this is congratulations again to everybody tonight, is the work we do is good and it compares very well with the UK trend. Sometimes there are differences, and those are the ones we need to concentrate on. The hair streaks, now unfortunately we don't have a decent measurement of hair streaks. Maybe I'll talk, if I have time, I'll talk about that a bit later. But it's simply because we can't measure it with our system. Transects are very poor at measuring the purple and the white letter hair streak, and we don't have enough sites with green hair streak. Yeah, you see here, the wall brown, 500% up over the last 6 years is an interesting number. Scotch Argus, which has appeared, it may have been introduced to begin with, but now it's on the spread. So as I was saying, Yorkshire is very much the northern limit. So many of these species are still increasing in abundance as they move up through the county, and they're also increasing their occupancy. Remember I talked about abundance and occurrence being two separate things. Well, tonight I'm also going to include occurrence in this over the last 30 years, and I think you'll be very interested to see some of that data. So our main driver for change, as you can imagine, is climate. That's a core one. And there's 4 times as many species increasing than decreasing here in Yorkshire and in the rest of the UK. So I must admit, I get slightly perturbed when I see always the headline figure, anything to do with butterfly conservation. The first headline you see from everybody is minus 82% loss since 1976. How many times have you heard that on the press? Well, yes, but it depends on how you measure it and when you measure it from. If you remember 1976 as well as I do, it was my last year in university, and it was, the summer was a sweltering as we did our exams. It was absolutely sweltering, and it followed 2 previous years, which were very good. And unfortunately, when butterfly conservation do their figures, it's always compared with 1976 because that was also the start of the UK BMS scheme. Ask yourself whether that would be the right year to start. So I think you've got to bear these things in mind. That 82% also includes all the species, not only that have lost abundance, but also all the species that have lost occurrence. And there's lots of species that have increased in abundance but decreased in occupancy because of the hostile environment they find out there in the modern world. You know, the farming has become even more intense. The other secondary driver in this, I think is a very important one, is nitrogen. And we're going to talk about a little bit more about that. It has positives and negatives. Now, nitrogen disposition, I don't know if you've been watching the news from Holland. Holland has introduced, because of some of the losses in its, because it's a highly agricultural countryside, as you may know, there's a new farmers' party, and they are trying to persuade the government not to introduce rules to reduce nitrogen disposition, which have been responsible for a large number of the declines in their butterflies, but also many other species. And the farming part looks like it's going to get a very considerable vote as the backlash against conservationists who the farming community sees us as an enemy. I've been a farmer for many years. Most of my career I was a farmer, and I would say I'm a bit more on the side of the conservationist. The important things to look here in the different species is the small skipper is showing a very long-term decline, and that's important. The pearl border fertility is particularly worrying. Now this year with the small tortoise is declining because it has a new parasite, which I'm just going to come to very shortly. It also hates dry, hot summers like 2022. It loves wet, warm ones like we had in 2020 and 2021. Both are large fertilitors, the dark green and the silver wash, both expanding very fast, almost exponential. They really are winners with climate change. The wall has changed. The wall almost disappeared from our lowlands. It was almost, well, it's very rare you ever saw one. They were around, just odd ones, but it's now staging a strong recovery. Marble white and ringlet is expanding very high abundance. I want to look now, I'm getting near the end, you'll be glad to hear, just at some of these species. The ones, and I picked out 6 species for us to have a look at in detail what's been going on. And you saw how abundance is very much determined by the weather. And you'll see here, this is the abundance small skipper. You see a big spike 2006, which we know is a particularly good year. And then the other good 2 years was the 2013, 2014. But then it stopped. And we didn't see the increase when we got to 2018, 2019, our next 2 good years. And you can see the slope of the line is most definitely down. It's reached the point where in some of our sites, we are losing small skipper. Some of the Yorkshire wildlife sites are getting down to 1s and 2s over a whole year, which is startling. My memory of the small skippers was always one of the most abundant of species. To match that, over here you see the last 20 years of occurrence. So this is percentage, the percentage of Yorkshire that sees small skipper. So it's started at 24%, is now currently at around about 16%. It's lost a lot. Now, normally we lose occupancy towards extinction. That's normally the case. So there must be quite a few places where it's going extinct, which is doubly worrying. Why could this be? What's happening? So I think this is where our nitrogen comes in. Nitrogen alters the habitat, particularly for a species like small skipper, which relies on the finer grasses. And nitrogen causes the coarser grasses to grow stronger and competes out the finer grasses. That is, I think, the combination of climate change with nitrogen is causing this difference. Add in the extra moisture, obviously that's also counter for finer grasses. And basically our soils are getting too rich for some of our species. Let's choose a different one, a very different story, Brimstone. How far it's moved in very short time. Just look at the occupancy. We've gone from 10% to 20%. That's an increase of over 80% occupancy. But look at the abundance, how far that's increased. So that's up 400% over since 2008, approximately. is one of the real big winners of climate change, and is because we're on the northern edge. It's not yet reached Scotland. It's into Durham, etc., but it's not really reached Scotland yet. That's partly because the food plant is very rare. The buckthorn plant is a rare species, but it is benefiting from when we plant buckthorns, which I know a lot of you have probably already done. And I think it's also important to say how much our butterflies have changed if we look back to the 1980s. If you wind the clock back to 1982, if we were stood in York, for example, there would only be half the number of species that we have now. And of all the species we count on our transects, over half of them have only just appeared in that last 40 years of time. So there's been a big switch from the early 80s, which was a turning point for our butterflies in many respects. The 75, 76 heat wave was followed by a very cold period. We had an almost mini ice age from 77 to 1980 that really did hurt butterflies. But since that point, it's almost been a steady rise with lumps and bumps that you've seen in the graphs I've displayed. But it's been almost constant. So we now have probably 24 wide-scale species. Back in 1982, we had 12 or 13. Just shows you how much things have changed. Holly blue. This is a little chap that causes all the problems. This is the ichneumon fly that parasitizes the eggs. So you see it here searching in the summer for eggs laid by the holly blue, which are normally laid just on the flowers, and the larvae eats the flowers. In a bad year, it's 99% mortality rate with holly blue. And you can see that mortality rate here on the graph. You won't see it on the currents, but you will see it in abundance. So you literally go 90%, 99% down, almost to zero, and then it bounces back, and then it goes down. And it's almost a rhythmical pattern that you see here, around about every 3 to 4 years. It's a big winner with climate change, up nearly 500%, and it is spreading because we are near the leading edge again of holly blues. They are one of the later arrivals. If you want to see them in profusion, cemeteries are the best places for holly blues because of the abundance of ivy and holly. I give a walk in and a talk in York Cemetery, and we see more holly blues than we see meadow browns. Just shows how abundant the species has become. Now, this is my favorite species, silver War Fertility. It's spreading so quickly that the occupancy is exponential. The abundance is not so much. It's still going up very steeply. We've got a dip this year because my transect, we've had a lot of work by Forestry Commission, most of it good work, but in the short term, it obviously destroys a good deal of the violets as they widen rides and clear areas. I mean, the machines they use are very heavy. But it's interesting to note how far it's moved. It's moved up the limestone ridge. So it's jumping from ancient woodland to ancient woodland, which is there's a chain of them up the limestone ridge, but also the tabular hills. So basically anywhere where there's gorges, limestone, ancient woodland, that's where it's really taken off. And this has all happened since 2017. It's a remarkable story when you look at the speed at which this is happening. The wall, I promised you a story on this. And you can just see here, when we go back 30 years, 1995, it was a common species. And even in year 2000 on the occupancy, it was occupying nearly 30% of Yorkshire. As millennia approached, it just dropped like a stone, and then it recovered very slightly. We did have a very, very bad summer. 1998 was a very, very bad summer, and then it recovered somewhat. But then some more bad summers. 2005, it just went down. And I remember, you may remember 2007, 2008, the wet summers. Remember the floods that we had midsummer. I'd never seen it quite as wet in a summer as 2007. And it just, that was it. That was the turning point. Those two summers basically were the death knell. There's been some brief reappearances. We knew it was still around, and it was basically, it survived on the hills and the coast. So places like Fodden, which is on the east coast, and on the upper end, above 300 meters or so, 200 meters, it's also doing quite well on very infertile soils, limestone usually. And then something interesting happened. 2016, things began to turn around. So I've blown this bit up here, which is the 2016 onwards section, and just made the scale so it's easier to see. And the increase is quite dramatic. It is on a very rapid rise, and that's reflected in your transects. So as I was telling you earlier, we've had, I think, another 8 or 9 transects suddenly have wall reappearing. They weren't there in the past, but they've reappeared in this last year. And the numbers in other locations have been increasing too. The last 2 years in particular, so 2021, 2022, it's been most noticeable. Will it continue? I think it probably will. If they can treble in just those few years, I think they're on an upward trend. So what caused the decline and what's causing the increase is an interesting thing to think about. And I think a lot of people talk about the suicide generation, because as it got warmer, it wanted to produce a third generation, but the caterpillar has to reach its third instar before it can hibernate. So it can have a third generation, but if the caterpillars don't reach the right stage by the time that November period, it's death, hence the suicide generation. And that was the thought based on some research which tended to show warmer areas suffered more than cooler areas towards the coast. But I don't think that's the complete story of the war. I think that it's very sensitive to nitrogen, and that has got a lot to do with the decline. But it's also adapting. It's genetically adapting, I think, to the changing circumstances. Some recent work in Sweden shows that it's been driven north by climate change. As it moves north, it's altering the time when it hibernates. So as it moves north, obviously it has to hibernate at an earlier time to cope with the changing seasons. And that's what's happened, to a point where the race in the north of Sweden is now completely separate, genetically completely separate from the ones in the south. It's adapted, much like the brown Argus adapted by changing food plant, and many other species have changed genetically to cope with climate change. So it's not all bad news, climate change. Species, it's an insect. It can adapt incredibly quickly. It has great ability to reproduce. If it can find a genetic way of changing, it's finding that opportunity. Let's move on. This is the sad story of the small tortoiseshell. And this is the new problem here. can you see these little white threads hanging down from the pupae? This is from somebody who's bred a load of caterpillars, and unfortunately he's been very disappointed because they were all parasitized by a little bug called Sturmia bella. It's a fly about the same size as a domestic housefly that arrived in 2002 and has subsequently spread through the whole country in a matter of about 5 or 6 years. And the variation in abundance, because of the new parasite, it gets over the parasite then dies out and then it comes back. But the peaks and the troughs are getting significantly bigger. But overall, the abundance of the species is increasing because of climate change, particularly when we get warm, wet summers, as we talked about earlier. Overall, occupancy is also growing, so it's up 20%. So surprisingly, abundance up 19%, occupancy up a similar amount. That's not always the case, as in the next. If people want to know more about the 30-year review and each of the species, then you will find in the Transect reports, you will find you'll find that graph, but you'll also see a lot of stuff which we've covered today here, and also all the graphs I've been showing you, but it now includes all species. So I had to be obviously time limited. It's only a certain amount of time, and I'm aware I can overload you with stuff, but it covers all species. So if you want to explore that, the reason I went and had a look at this is the small white is particularly interesting. From 2002 to 2012, it had a very, 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 very bad time. This great big peak probably is a migration, and in 2018, both of them were cracking good years. I expect that was either migration or local breeding, and you're left wondering about this area here, which is very poor. But maybe you wouldn't be surprised if I said the year neonicotinoid pesticide was introduced wide scale on use on rape crops was, guess, 2002. The year it was banned, 2012. Boom. It's purely circumstantial evidence, but pretty good in my opinion. There's no real evidence to connect, but I think that is very strong circumstantial evidence. You'll find all the different species here, the parasites, etc. So if you want to go and explore that, I also look at the flight curves for different altitudes. Another very interesting thing when you move like common blue, the reason it's become more abundant is on the lowlands it has two broods, and the uplands it only has one brood. And you find that changes. So you see on the lowland there's a little lump here which corresponds with the lump of the upland. So that's a proportion of the species is doing one generation, but the vast majority are doing two. And as the weather changes from year to year, that percentage also changes.